Good morning, good afternoon, and good evening, depending where in the world you're joining us from. Welcome to our webinar, Building Agent-Ready Data Architectures on Google Cloud, brought to you by our friends at Striim. I'm Brian Mink, co-founder and president of Data Science Connect, the world's largest data and AI ecosystem for enterprise leaders. Today, we're excited to welcome hundreds of attendees from around the world to explore how to leverage real-time operational data to power enterprise AI at scale. AI agents are only as effective as the data they can access. Yet most enterprise architectures still depend on batch pipelines, fragmented systems, and tightly controlled operational environments that limit real-time context. Today, we'll explore how continuously refreshed data supports goal-directed reasoning in AI agents, improves memory retention through up-to-date context, and enables dynamic planning in real-world operational workflows. Just as importantly, we'll address governance, observability, and architectural flexibility, so teams can modernize without compromising compliance or performance. We're honored to hear from a distinguished pair of experts today. Jake Bingston, VP of AI Solutions at Striim, and Schneider Larby, Senior Manager, Partner Technical Architecture, Co-Innovation Group at Google Cloud. Before we begin, a few housekeeping items. To make this feel a little more in person, we suggest you add a photo to your profile and include your bio, LinkedIn profile, and other information you want your fellow attendees to see. If you're wondering where your organization stands compared to others on your AI journey, check out the poll question in the right sidebar. And finally, to learn more about how to build agent-ready data architectures on Google Cloud, check out the calls to action below throughout the webinar from our sponsor, Striim. Now, without further ado, let's kick off our webinar.
Hello and welcome, everyone. Thank you for being here today and joining us for this webinar on building agent-ready data architectures on Google Cloud. I'm Jake Bingston, VP of AI Solutions from Striim, and we're very excited to have with us today from Google Cloud, Schneider Larby. Schneider, go ahead and introduce yourself.
Yes, thank you, Jake. My name is Schneider Larby. I work as a senior manager for the Global Partner Technical Architecture team. So we work with different ISVs to build different co-innovation features and solutions on top of Google Cloud, and I'm happy to be here today.
Awesome. Well, thank you so much. We really appreciate it. We're excited to learn all the things that Google Cloud has to offer. So I thought we'd start out just a little bit, set the stage for where we're at. You know, it's been a real whirlwind what has happened in AI for the past few years, starting just as recently as 2022. As everyone remembers, it began with ChatGPT, the fastest application to gain over 100 million users. And from there, we saw lots of other companies start to release innovations in this space. We have Google with everything that they've released with Gemini. We've had others enter into the ring. In 2023 is when, from our point of view, started to see a lot of experimentation. Everyone was starting to build like a RAG application. We started hearing a lot about fine-tuning how you could make these LLMs work for yourself specifically. And then in 2024, a lot of organizations started trying to get into production. But it proved to be maybe a little bit trickier than we thought it would be. There were some groups like the Nanda group that did a survey last year that found only 5% succeeded in moving into production for task-specific generative AI applications. And now today, where we're at is the talk is all about agents. Everyone wants to know how they can leverage agents. Building agentic AI is the real nomenclature that we all hear about. And what we'll be talking about today is how we can leverage a lot of the Google tooling that's available and how Striim can work with that. One thing that is for sure that agents have changed the ways that you need to be able to present your data and work with your data. We're rapidly moving from the experimentation phase into the production phase. And as we go through that, it's becoming clear that there's some things that agents need to be able to be successful. For one, they need continuous context delivered to them. And this is, that real-time operational grounding. This isn't just data given to them once a week. And so some of the systems I've designed before don't really fit the bill for that. And other things, they need low latency systems. They need autonomous systems. They need to be able to act upon that. They need tools. There's lots of different things in this area that are changing that are required for agents to be successful. One thing that actually just came out recently, I don't know if you saw this, Schneider, but the National Bureau of Economic Research released they did a survey, and they surveyed about 6,000 executives across the US, UK, Germany, and Australia. And some of their findings were really interesting. This has been making the rounds across LinkedIn and X and other places. But essentially, according to these executives, only 89%, or I guess 89% said there was no measurable productivity gains from AI yet within their organizations. And that's something that maybe goes against what we're hearing across, there's lots of doomsday, AI can do better things than everybody, it's replacing jobs. But I think what we're seeing up until this point is that AI has been seen to be useful, but is not really unlocking maybe the types of productivity gains that we thought that it would, or think that it's possible to. However, if you read further in this research, they are optimistic for the next 3 years. So this is really looking at, the last 3 years, what have you seen? I think right now we're at that inflection point where we're going to start to see a shift because of the release of agents and because of the ways that organizations are starting to think about their data and how they can unlock their own data to be able to make their agents more useful. One thing, if we think about the way that data has been handled in the past and the way that data infrastructure was set up, I think everyone at some point, every organization has built a warehouse. And these warehouses were built over the past 10 years, but they were built with a warehouse mindset. You have to think about why a data warehouse was built in the first place. Often it was for reporting purposes. You had a weekly report that needed to be run. That weekly report needed data from the entire week. It didn't need data from the last second. And so you're able to build these large batch jobs that centralize the data daily, maybe even weekly. Maybe you were very advanced and you were doing it twice a day or something like that. This data was perfect for dashboards that you could look at a static point in time, but was not ideal for really real-time systems. And so now with agents, the need is for data that they can rely on to make operational decisions. They need to know what's happening in the world today, right now, and so they can make decisions based upon that. That's kind of some of the power that they really unlock. And so naturally, as data science teams started to build these, they may have an experimentation use the data warehouse that was established. But once you start to move in production, you realize, oh, actually, this data is stale. If we want to simulate a real life scenario, we need to connect these operational data stores. Obviously, the operational data teams do not allow access to agents to be able to get this data because they're non-deterministic systems. We don't know exactly how they're going to act, what they're going to query, how many queries they're going to write. And so they said, no, you have to get it from somewhere else. And so now what we're starting to see is a shift from the stale warehouse to start building more of these real-time live operational lake houses. So bring your data together in real time, low latency, so that the agents can consume from there and be able to make those operational decisions. These are more often than not, more and more we're seeing them owned still by data teams, but sometimes they're starting to be owned more by platform and app teams. It's just a real shift in the way that we're thinking about data and how it can be leveraged. It's not just for reports, it's for these agents to be able to make decisions. At Striim, what we've seen as organizations go through this realization is essentially they follow kind of 3 stages of real-time data maturity. And all of this is in support of their enterprise AI strategies. So the first one that they go through in maturity is that they're just trying to get to the cloud. Oftentimes, a lot of the AI tools that they want to use are in the cloud, and they need that data there to be able to be ready and accessible. And so they go through a cloud migration and adoption strategy. It's just like a lift and shift. Their database was on-prem. It wants to be in the cloud now. The second stage is where they start to go through data and platform modernization, which is all about building modern data architectures. This is, the most common is a lakehouse now, or I'd say the newest way to think about this, but this was often called the data warehouse, a data lake. You could use the term fabric, whatever you want to call it. This is unifying your data into a centralized location to be able to support your enterprise AI strategies. And for Striim, this means really bringing that data together in real time, not in batch, right? We want to make sure as soon as that data is born somewhere is that it can make it into your data platform so they can be accessed by those agents. And the third stage of this real-time data maturity is once organizations start moving to event stream processing. So this isn't even just moving the data into one place and then doing the analysis. As the data is born and moved, that data for Striim is moved in memory. And while it's moving, it can be actually analyzed in real time. And we can identify events that are of interest, and those can inform other actions. And so in an ideal world, agents are able to act autonomously. They're not having to be triggered by a manual process. And the way that they can be triggered autonomously is through event stream processing. We can write, hey, this situation happened, this customer made this decision, we analyze that decision is sent on to a pub sub layer, then the agent picks up from there and is able to act upon that and respond in a timely manner to that customer situation. Striim with Google Cloud provides all the tooling you need to be able to set up really the modern data architectures for this. We have connectors for Striim to be able to get data from really like any of the data sources that you may have today. One of our, I would say, superpowers is change data capture out of massive operational databases like Oracle or SQL Server and others. We can use change data capture based on log transactions, and we can pull in that data and deliver it into Google Cloud. But we can also connect to like messaging queues like Kafka, NoSQL, sensor devices for your IoT use cases. As the data moves along and moves in real time, like we talked about, you can actually do lots of activities with that data, right? We can enrich it or filter it. We can aggregate it. We can even add vector embeddings along the way. All this is be able to provide it to Google Cloud to do a lot of your data analysis. So whether it's the data platform modernization play, where we're delivering data into BigQuery or Spanner, or if it's more along that event stream processing, where we're going to deliver that data into Google Pub Sub. And then this all supports the ability then for Vertex AI to take that data, build out your agents. And we're really excited to have Schneider here today to talk about it from the Google side of things, how Google is able to provide that advanced capability.
Thank you, Jake. So like Jake mentioned, the term agentic or agents has become a very popular term in these days. And so to understand how all of this intersect with the offering that Striim has, let's just take a step back and let's talk a little bit about what agents are, right? So essentially, when you think of agents or when you hear the term agents, it is actually a simple software entity that has the capability to plan, to make to reason, and not just plan and reason, but also have the ability to execute tasks on behalf of its users, right? And when you hear of agents, agents actually come in 4 key components. All of this makes up agents. The agent has a brain, right? And that brain is the underlying AI model. And this model could be Gemini, or if it's on Google Cloud, or it can be another third-party model, even on Google Cloud as well. And it also have tools. And these tools is what these agents use to fetch data and to perform certain actions and transactions, right? By making calls to different type of tools for different purposes. And one example is that is how an agent will be able to communicate with Striim as an example to analyze data that is in transit and make sense out of that data, right? So that is what the tools are. And then we also have orchestration. So whenever you have an agent, that agent needs the ability to maintain memory and state, which is very important. I don't know of you if you have checked on, a very basic agent that is not an enterprise agent. You would usually chat with that agent and you ask it another question, and in about 5 minutes, it cannot remember what you were talking about previously, right? So such an agent is stateless. It doesn't have memory. But here we can have a real enterprise agent has that memory and that ability to maintain the state of the conversations that it is having, right? And then finally, the other component is the runtime. So everything needs a runtime, some kind of compute in order to run everything and make it work. And essentially, this is what makes up an agent. So all of this runs on top of Google Cloud, and it integrates with many different applications and software and tools, specifically like Striim, as we're talking about today. And I'm going to go a little bit more deeper to explain what these agents are and how to build them and how to integrate them with a system like Striim to make it more useful, right? There are ways of deploying agents. When you build an agent, it is essentially a simple, block of codes that you write to define what the agent is, what the agent does, specify what model that agent is going to use, and then you define the tools that this agent is going to call in order to get data. But after you're done with that, that agent needs to operate at scale somewhere. So usually when that is done, you have to package that agent into a container. And when you do that, you have a couple of options on where to deploy it on Google Cloud. You can either deploy that on Vertex AI agent engine or on Cloud Run. Cloud Run is our serverless compute that we have on top of Google Cloud. So Agent Engine and Cloud Run are fully managed services. What does that mean? That means that when you deploy your agents there, you don't need to think about provisioning of compute in the background. You don't need to worry about configuring networking and all of that. You don't need to care about that. What you care about is building your agents, focusing on what the agent should do, and maybe enhancing the quality of that agent. Then the other deployment option you have, which is self-managed, is to deploy this container onto GKE, which stands for Google Kubernetes Engine, as a container, and then you manage everything yourself. And to do that, that means you have to provision this GKE clusters, you have to provision the node pools, you need to provision storage, you need to, if you want to implement, caching, you have to deploy Redis, among others. You have to do all of this yourselves, right? So these are the paths to deploying agents on top of Google Cloud. But if we dig even more deeper into it, what are some of the benefits from using each of these options as I'm talking about? If we talk about the Vertex AI platform, we talked that every agent needs a runtime to operate. So you get that runtime out of the box. It's nothing you need to worry about. Now, if you have built an agent and you are having even millions of people accessing that agent at the same time, you don't need to think about scalability of how to scale these agents. Also, when you want tools that will connect to other external systems, you can get built-in tools here as well. And we also have built-in RAG engine. So RAG is very useful for agents, right? What is RAG? RAG stands for Retrieval Augmented Generation. So that system is what prevents the agent from hallucinating or from giving you false information. It helps the agent to be grounded with facts that comes from your own enterprise data that comes on Google Cloud, right? And so a RAG system can be built and put in front of the data that is streamed by Striim as an example to ensure that whatever response the agent will give you comes from that streamed data and not something the agent or the model is talking about that it doesn't know, right? And then we also have search support on there, which allows you to use Google search to augment the capabilities of your agents. So you can see that if you use the Vertex platform, you get all of this and many more. And then for the serverless, as I spoke about that allows you to do scaling in amazing ways. For example, if you're not using the agent at all, it scales back to zero, which means you're not paying anything for it, right? And if you decide to use it to, the code starts very quickly, and then you're back in business, it can scale a lot. So that's also another thing. But when you run it, it's serverless, but in terms of how you customize your agents, you still have to work on some customizations, with regards to the tools you want to use and the grounding and the RAG, among other things, right? And then we have the custom GKE. So the GKE, which is the Google Kubernetes Engine, gives you a lot of flexibility, right? Because if you look at the Vertex, we have specific AI models that you can use there. Not all models are supported there today. We're still working at adding more models every day, but it doesn't cover all models. But for GKE, you have the ability to go to a place like Hugging Face and get a specific model of your choice. It doesn't have to be Gemini, it can be any model, and you can bring that on top of Google Cloud. you have the option to also select your own GPU type that you want for running your models and inference. You have that flexibility. And so, as you can see, quickly, we give customers like you the options to run at scale on top of Google Cloud when you decide to run agents. And all of this, once again, I like to iterate that it helps you to have a better platform where you can have a system like Striim bring fresh data that was your agent can synthesize to give grounded and useful responses to its users. Now, I'd like to dive a little bit deeper into our agentic capabilities that we have on Vertex AI. So, if you have played with Vertex, you can find what we call the agent builder. It is actually a feature within the Vertex, and that has a host of capabilities and tools that allows us to build agents at scale. And one of it is the Gemini CLI. For those of you who have played with it, this is an amazing open sourcing tool. Open source tool that we have. It is like a coding agent that supports you to build different type of agents. And the underlying model is Gemini. We also have the agent development kit. We've also made that open source, and it is actually a framework that helps you to build agents, evaluate them, and do it at scale on top of Google Cloud. And you can package it and take it elsewhere too, right? And we also have MCP, which is a protocol that allows you to have connectivity to external data sources to give context to large language models. We'll talk about that a bit more. And then we have Vertex AI Agent Engine, which is essentially a managed platform where you can deploy, manage, and scale your AI agents. Today, many organizations hesitate to use agents for several reasons. Some do not have visibility into what the agent is doing. Some do not have visibility into how it arrives at this decision. Some do not even understand how they can evaluate agents. All these concerns have been addressed when you are running agents at scale on Vertex Agent Engine today, right? You get the visibility into what is happening. You can do evaluations of the agent's actions, among other things there, all of it there. And more importantly, we also launched another capability that we call the A2A, which stands for the Agent to Agent Protocol. So that is also something we've made open source, and it actually enables communications and collaboration between agents. So think about an example, right? Imagine you are a fashion vendor and you can tell your agents to increase the stock of specific t-shirts from Nike. Then the agent is able to talk to Nike's agents and make the order and then make the shipments and organize everything for you without human intervention. That is possible today because of this protocol that we have, launched, and we use that in different type of customer use cases. And all of this ties in the story of Gemini Enterprise that you see below. So Gemini Enterprise is actually a platform that gives access to AI agents to empower employees within an enterprise. So basically, this is a platform where you can connect all your data sources within an enterprise and have agents take actions on behalf of it. So for example, in your enterprise, you could have something like Workday. If you have Gemini Enterprise, you can go to the agent and say, hey, I need you to check how much vacations I have left. And if you know what you have left, you can now tell the agent, can you go ahead and book a vacation from X date to Y date on my behalf? The agents are able to take actions on your behalf. And that is a system, and all the underlying technology and features that you see mentioned here integrates with it. And what makes it amazing is the fact that the data sources that you have connected to Gemini Enterprise, you can continually make that data fresh by using something like Striim to always stream fresh data into these data sources, which can be used for context for your AI agents to give you something that is really grounded something that is really current, and something that is really relevant. So this slide here, in a nutshell, shows you what we have here at Google. The slide below is what we have for developers. Now, without data, AI is essentially useless, right? So you can see here that when it comes to tools like grounding, retrieval augmented generations, we have all these tools here. We have specialized agents that even handles data by itself. We have enterprise context where we have several kind of connectors, like connectors that will connect SaaS systems like Salesforce, among others, to allow you to get your agents to act on that data with LLMs or large language models, to give you whatever actions you want to take or to get whatever results you're looking for. And we host all these ecosystems all in one place. We spoke a little bit about Agent Development Kit, which allows developers to develop agents at scale, giving agents context like memory, managing sessions, evaluations, login, and so forth. And it doesn't end there. If you look at models, we also have a ton of models. If you go to the Vertex AI model garden, we have more than 100 models. I've actually lost count of how many we have right now. And these are all third party, besides the first party state of the art Gemini models that we have. And this is what we have for developers who want to develop at scale, have the flexibility to build their own thing on top of Google Cloud. And it doesn't end there. If you look up there, we have what we are calling the AI applications. These are built in a no-code fashion, which makes it easy for a layman just to use a few definitions and a few clicks just to build an agent ground up and connect it to a data source, right? That's what Agent Designer does. We spoke about Gemini Enterprise, which can serve as a platform for your agents, both first-party agents and third-party agents, or what we call custom agents that you would build yourself and register it to this platform and make use of it. And then we also have Customer Engagement Suite, which allows you to have like an AI-powered, customer engagement center that is also automated with AI agents that assist human representatives in offering customer support. So as you can see very quickly, you are realizing that there is almost nowhere where you can have an ecosystem like this, where you have your data in the same place as you have your models and tools and frameworks and systems to effectively unlock the data that lives within your enterprise and make it valuable and make impact out of it. And we're offering all of this on top of Google with accelerators like Striim that helps us to even make this data more useful and fresh for the AI models to help us to make sense out of it. But now, here is the flow of how you want to build an agent. If you're thinking about how do I build agent, it is actually straightforward, right? So basically, you just need to think about what framework do I want to use? Do I want to use Agent Development Kit? Do I want to use LangChain? What do I want to use? Once you identify that, you just create your agent instance, and usually you would create that into Agent Engine. It gets deployed, and then from there you define your agent, give the agent its task, give it specific tools it's supposed to use to take specific actions. And once you deploy that, right, you get a session that is deployed with that agent. And the more people use that agent, different sessions are created, and you have the ability to manage that session. And on top of that, enable what we call the memory bank across these sessions. And when that is enabled, then now you're giving memory to your agent. You can now ask the agent different kind of questions you've asked previously, and it's able to use this memory bank to give that context to the agent, so you have the right set of information that you're looking for, right? So once you have this done, the next thing you want to do is to configure your agent runner, and this agent runner works within the agent development kit, where you define that either using a template, or you can create one from scratch. And you can also use a third-party template as well to create all of these things and then deploy your agents into production. So essentially, these are the high-level steps of how to do this. But again, as Google, we offer a lot of support to our customers and partners. If you are curious in learning the hands-on, we do have a lot of courses available to help you do this. But one key thing that I want to touch on, which actually ties in with our topic for today, as to how Striim is working to bring fresh data to your agents and to underlie models for better performance, is this model context protocol that we call MCP, right? Now, this MCP, you can think of it, is actually an open source system that was originally built by Anthropic, and it actually standardizes how AI applications connect to external data sources and tools. And it operates in a client server, manner. You usually would have what we call the MCP host, right? This is usually a user-facing AI application, or it could even be your agent that serves as an MCP host. And then we have what we call the MCP client that actually operates inside the host. So if you have an agent, that agent can be the MCP host, and it can also have the client within it. And then we have MCP servers. These MCP servers are actually lightweight, specialized programs that are designed to expose data sources or tools to the MCP client, right? Like you see here. So you can think of the agent to the left as the client there, and the underlying brain for that agent is your AI model. And then the tools there is what that agent is going to use to execute actions. So what the MCP server is doing is that the MCP server exposes the data sources and tools that it has available. So as you can see here, for the sake of example, the MCP server can say, hey, I have access to BigQuery, I have access to Cloud SQL, I have access to Salesforce, I have access to so and so, right? And I have the required tools to fetch data, to generate data, to pull data, and so forth. So when the agent is asked a question that has information stored in that external system, based on the instructions the agent has, it would now use that client to initiate a handshake or a conversation with the MCP server. And then the model knows which tools to use and where to go and fetch that data and bring that data back to the agent. And how Striim ties in here is that Striim actually supports this MCP protocol here. So basically, as we heard Jake mentioning, if you even have the data coming in transit, your agent can still work with that fresh data coming in transit, because we have the tools that would evoke that data source that Striim is streaming to and pull that data to the model for the model to give you the correct response or the right, let me say, context that you're looking for. So as you've seen here, this protocol is a very useful protocol that integrates with Striim and many others to allow you to connect to external systems to get fresh context for your data for the models to use, and then in turn give that response to your agent for the agent to give that update back. And one thing I like to highlight here is that at Google, you may be thinking, okay, how do I build an MCP server? How do I do all of this? So today, Google offer what we call MCP Toolbox for databases. So this is a managed service where we have the MCP there, and we have built the tools that connects to almost all of our database sources. So using those tools and making references and building the configuration to your agents can allow you to seamlessly connect directly to data sources on Google Cloud. And these data sources could be targets for your Striim system to stream data there, or you can directly stream it into PubSub and then directly to wherever you want to take it to, But then this protocol or this managed protocol allow you to make those connections to those data sources and get fresh data context for your agents. So in a nutshell, this is what we're doing on top of Google Cloud and working together with partners like Striim to be able to bring fresh data to make sense out of it for your agents to help you unlock real value out of enterprise data. So at this point, I'll hand it back to Jake, and Jake would actually discuss to us how all of this tie into the real-time intelligence systems that Striim is pursuing with us.
Now, really, the key to all this is that your data is your differentiator. At the end of the day, everyone has access relatively to the same models. And so now the way that you differentiate from your competitors is by bringing in your data better than anyone else to be able to add in that context. So the LLMs and the agents can know what to do and how to. And when you can really tie that in, that can become your secret sauce for your organization to unlock these new use cases. What I see going forward in the next couple of years is that organizations will get better and better with their data infrastructure to support these AI use cases. And at Striim, this is what we're very focused on providing for you, that message layer or that data layer to be able to connect your AI to the rest of the world. And we're happy to partner with Google Cloud on this process that we're going through. And so you think about all the different ways that we can work with, and we do work with Google Cloud, is through just your very straightforward ingesting, processing, delivering your data into locations like BigQuery, or be able to deliver the data to Vertex AI. We're helping organizations derive insights from that data as we move it along. We're also trying to just streamline your workflows. So we have the ability to a tool called Striim Copilot that allows you to be able to use natural language to set up these pipelines to make it easier for you to get your data from point A into BigQuery or other data sources in Google Cloud. And then lastly, as you're moving that data, we have the ability to apply agents as the data is in motion. So identify things like anomalies, create vector embeddings, discover PII data. All that stuff is built in partnership with Google Cloud to be able to give you a seamless experience as you go through this data journey. There are a few sources that we have. If you want to learn more about our partnership with Google, we've released a few benchmarks on, one is the world's #1 fastest database replication benchmark published by Google Cloud. We worked on that with them to be able to demonstrate how you could replicate data from Oracle into Google Cloud. Then as well, the last one there, industry's fastest integration benchmark with BigQuery. So we're very excited about our partnership with Google. We appreciate their support. We continue to deliver data to customers as they try to solve some of the largest data challenges. And we thank you for your time today.
Thank you.
Thanks, Jake and Schneider. Excellent insights, and thanks all of you for joining us today. If you missed any of the webinar or you want to rewatch anything, you can refresh this page right after the webinar concludes, and the recording will be available in just a few minutes. We'll also send out a link to the recording on our YouTube channel tomorrow. I want to say a special thank you again to Jake and Schneider, and of course to our partners at Striim for making this excellent webinar possible. See all of you again next time. Thank you.